In order to start measuring the mathematics of the waves and all that, I just need to talk about just a few things. So as we talked about, this was the screen, and what happened was when light entered this way, oops, let's do that, when light entered this way, right? The diffraction pattern on the screen was very intense here, and then it faded somewhat a little bit here, and then it just starts fading a little bit, but it's sort of equidistant each time, so it's a little bit less here, and then it starts to fade over here. So in other words, these parts over here are where this is constructive interference. Constructive. So constructive. All these are where the constructive interference happens, and then anything remaining, so these parts, are where the destructive interference happens. Destructive interference. So what that means is, sort of as a visual, is roughly speaking, it sort of looks like this. Let me try a different color. Is that over here, if the waves sort of merge over here, the light waves over here will interfere constructively, right? And the same goes with, let me try a different color. Let's try red over here. The same goes with something like this, right? It will interfere constructively from both slits. Whereas for some region like over here, let me try a different color, it will interfere destructively. So in other words, one will go like this, and then the other one will go destructively. So as you observe over here, the crest and the trough don't sort of pair up. In other words, it's shifted half an amplitude. If you remember from our earlier lesson that we get destructive interference, complete destructive interference, when the amplitude is shifted by half an amplitude. And so that just gives us sort of an overview, just before we head into the mathematics of constructive and destructive interference on the Young slit experiment.